How can traffic noise help in finding sustainable alternatives to mobility? NoiseWise will show you.
This is Shimon and this is Pavel, and the challenge that we are working on is to find a way to gather data on how residents move between rural towns and villages. This was a challenge given to us by an industry partner called CTU. The way we decided to solve this challenge is to use a smart sensor that can track how cars move between municipalities, and this data will be used to optimize the availability of public transport and other sustainable mobility alternatives, which will hopefully decrease waste from unnecessary car trips or car trips that are redundant thanks to other alternatives. Before I explain how exactly we use the data to do that, I will first explain how we created the sensor. So we set out a couple of design goals for ourselves. Our goal was to create a low-cost, smart traffic sensor, which is easy to deploy, has relatively low infrastructure requirements with no intrusive roadwork or difficult installation requirements, and will be optimized to collect traffic flow between municipalities in rural areas. So not exactly like congestion or something like that, but how many cars move between towns and cities. Our proposed solution is a wireless, solar-powered smart sensor that detects and classifies vehicle types using traffic noise levels. Here's a quick overview of how the hardware that we eventually built into a prototype looks. The core of it is a Raspberry Pi, which is a microprocessor connected to stereo microphones, a solar panel for power, and using a GSM module for a data connection to be able to send back data to a cloud database. The way the actual software works behind it is that we take the two audio waveforms, run them through a bunch of filters, then run position analysis on the audio waveforms to be able to determine which directions the vehicles are moving. We throw that through a MEL spectrogram into a neural network, which will then classify what kind of vehicle it is, whether it's a passenger vehicle, truck, motorbike, or not a vehicle at all. And then we aggregate information from this sensor and hopefully many other sensors like this from all around certain regions into a database, which will visualize then how vehicles and traffic moves between municipalities. So this is a mock-up we did initially of how it should look. This is our first prototype. Here you can see our second prototype. So we actually built the thing, and we decided to, look why our solution here is better than any other solution that we've looked at for this specific use case. First, we looked at whether we can use a mobile app to track this, but people don't like to install random mobile apps that track them. We looked if there's any existing data sources, and there are, but they're usually not exactly useful for what we're looking at here. There's public data sets, but those are usually short-term surveys. There's private companies that provide this data, but it's usually expensive and measures things like congestion, which is not what we really want. We can get satellite or other GSM data, but that's usually very, very expensive. Or we could use other existing smart sensors that already exist in the world. However, those are usually optimized for cities, and it's usually things like induction sensors built into the road, or magnetometers, or traffic cameras, and those require infrastructure, maintenance, and a lot of upfront cost, which we want to avoid here. So we took these three sensors, and now to explain how this actually brings about a sustainable outcome, we ran a quick case study in the town of Libeň-Libeř. It's a very small town just outside of Prague. We placed multiple sensors around each of the main roads leading in and out of the city, and basically tracked how many vehicles were coming in and how many were coming out, and thus we were tracking how residents were coming into the town and where were they going. We then also used a questionnaire to measure the demand of residents for sustainable mobility. So we were asking where they go, how often they take a car, and whether they would be willing to take a sustainable alternative if given the chance. And our aim was to check whether our data correlates with any kind of demand for alternative mobility solutions. Now, this was a relatively recent case study, in the last couple of days, so we don't have a lot of data yet. We don't really have fully representative results yet. We're going to need more time for that. But anecdotally, so far, it looks like our data can reasonably predict where people might want to go during the day and take public transport if they had the option. Because, of course, in small rural towns, a big problem is the availability of buses. Buses might come once every couple of hours, which is not great if you want to just go for a quick trip somewhere. So yeah, so far it looks good, but of course we will need more time and data. We looked at how much our prototype costs. It was around 3,000 crowns, so in euros that's about 120 euros. There you can see the full bill of materials. But this is using prototyping materials which are usually pretty expensive. So a cheaper solution, or a production version, might be much cheaper, almost half the price, so around 60 euros, which is incredibly cheap for a sensor with these capabilities. Commercial solutions such as magnetometer sensors or traffic cameras can go from thousands to tens of thousands of euros.
And the time has run out.
Okay. Sorry. Well, yeah.
Okay, but we have time for questions. So, member of the jury.
Okay, hi, thank you. First, a clarifying question, is your sensor also able to detect like electronic vehicles? They make quite significantly less noise?
Yes, so the electronic, when we were testing this out, the good news is like when you're on the side of the road and you have a sensor on the side of the road, most of the noise that comes from a car is actually the tires. And yes, so like engines will make different noises, but we've noticed that with a large enough data set, it's reasonably accurate. It doesn't have to be 100% accurate for the purpose that we're using here, but it's good enough to be actually able to track vehicles.
Okay, thanks. And then other question is, how are you going to make money on this? Could you elaborate on the business case?
So I didn't have time to look into that, but there are multiple options. So one was looking into working with an industry partner who gave us this challenge because they were looking to use this for their own market research. They do sustainable mobility solutions in rural towns like this. We're also looking at possible subsidies that could help us create and then sell these sensors directly to municipalities, because governments often have digitalization subsidies. There's a new Intelligent Transport Systems Directive at the European Union level, which is providing guidelines for countries and cities on how to exactly promote solutions like this. So we're hoping to address those kinds of people and to provide it as a commercial solution to them.
Other questions?
Well, not a question, just if your commercial partner is not supporting you enough, we have an incubator at Czech Technical University and ask.
I mean, just to actually say something about that, they graciously offered to give us access to some of their data sets to run a larger scale case study, which we are definitely thinking about looking into, but that's going to be a future thing because it's been a relatively short time frame which we had for this.
Okay, thank you. It's impressive to see the prototype and how you explained how everything works technology-wise. But I want to go back to the basics and actually ask you, what exactly is the problem that you are solving? Because you just describe here that you want to do it, but why do we need this kind of data and who can really benefit from that? So
I think people in small towns often have an issue that you basically need a car to survive in a small rural town, right? If you want to go somewhere, you don't have much of another option because public transport is relatively inconsistent. So yeah, people might use a bus for their daily commute to work, but if you need a short trip to go somewhere in the middle of the day, you might not have an option or you might not know about an option. If we can provide real-time data that can show companies or cities where people want to go, then we can theoretically optimize that the availability of their solutions to when people need to go where. So that's one option. I didn't get to this, but there's actually other uses as well in terms of sustainability. You can monitor road usage and wear, or the amount of waste from vehicles, which is sometimes hard to do in a rural area, because like in towns, of course, you got sensors, you got cameras everywhere, and like lots of studies. But in a small town somewhere else, they might not actually have the data unless they do expensive surveys, and this is a cheaper option to do that.
Okay. I want to explore this a little bit further, because on the one hand you say we're going to have real-time data in a mobile app,
yes.
And on the other side you say we're going to provide this data to municipalities.
Yes.
Did you validate that the people working at municipalities who are interested in data about how people move, what the usage and where is, that they need real-time data and that they want a mobile app?
So the real-time data requirement actually, or the reason why we went for real-time is because we were also looking at giving it to companies. For example, when we were talking to our industry partner, they were saying that they use basically, it's a ride-sharing system, and they were thinking about using this data for pre-positioning of vehicles. If they can see a spike in demand somewhere, we would theoretically, or they could maybe train predictive models on data like this and be able to use that.
Simple yes or no. Did you speak to a public servant who has in his job description that he is responsible for traffic, public transportation, or something like that? Yes or no?
Not specifically traffic transportation,
Okay.
but
No.
public servants, yes.
Okay. Thank you.
We have like 30 seconds left. So it has to be a really fast question and fast answer. All right. Do you have another member team with you here in the hall?
We have our
All
team
right.
back there.
So big applause for the NoiseWise.
Thank you.